Hey, thanks, Dan. Welcome back, everybody. This day has been kind of amazing, very exciting, very educational for me. I think we've got most of the panelists back. So Michael and I have discussed a little bit about how we might do things. And I know we were kind of constrained on the time. Dan, I was actually quite amazed and impressed at how great a timekeeper you are. I imagine that there are burning questions from many of you. And I do want to, ultimately our goal is to move forward on how do we get these, this type of codification that Dan was talking about. How can we get the policies and things like that forward? And this is just the first day of a much larger effort. Towards that, I think it would be useful just to allow people to ask those burning questions. And then if there aren't, gaps and things like that, I've got a couple things that I would like to bring up. And Michael, I think, is essentially, the world's expert in much of what we're talking about. So he will chime in and add his 2 cents as appropriate. So let's start. If anyone, I think the easiest thing to do for now is if people have questions that you weren't able to ask. I know there are several during the people's talk. If you want to do a raise hand, and we can do things that way. And then if it turns out to be too many raised hands, then we can start going to chat window as well. All right, Victoria.
Hi, thank you guys so much for a wonderful day of talks. It's been really interesting to hear all of the different perspectives and the interdisciplinary nature of this idea. I'm curious really from everyone how we start incorporating these discussions, these sometimes hard, uncomfortable, and even messy conversations in our classroom. I am a first-year PhD student and took a bunch of classes this semester. Professor Taylor happened to be one of my professors. And I think that I would have liked to have seen more of these discussions so that I could have been more prepared going forward in my career in autonomy to have answers and ideas to have at least thought about what are the moral and ethical implications of lethal autonomous weapon systems if I'm ever put in a position to deal with that type of conversation. Are there initiatives or natural ways that these types of ideas can be addressed in a curriculum? Do you need to be a philosopher to ask the question, or are there ways that engineers can start addressing that in the classroom as well?
So this is clearly an engineering question, but not an easy one for engineers to answer. CJ, do you think you might be, as a PhD or a RoboMasters?
Sure. No, this is a great question. As always, as you probably have noticed, Victoria asked nothing but great questions. So I was very privileged to have her in my class, and I apologize for letting her down by not having this discussion sooner in that context. But no, Marcus, per usually you put your finger on the spot on it. I think we all feel very comfortable talking as engineers about equations and about the underlying technological issues, this is something that's a bit further afield from what we tend to do. In the undergraduate curriculum, we're able to take advantage of expertise sort of outside of our school, and we have classes like ethics that are embedded and required parts of our curriculum. There may be a reason to consider something similar at the PhD level as well.
I wonder, Mark and CJ, if we could get commentary by Britt Shields, who I understand is teaching many of those undergraduate courses. Is Britt here now? I saw her earlier, so.
Yes, I am. And thank you so much, Victoria, for this amazing question, and CJ for your comments. As Vijay had mentioned earlier, I am teaching a couple of these courses for the undergraduate engineering curriculum. And what we actually started piloting this year, this past academic year, is integrating ethics more into the core required classes as well. So for example, Bioengineering 100, we ran a series of bioethics modules. And in a SIS class, a deep learning class, we ran a series of ethics modules. And so, we're hoping to be one of the leaders, among our peer institutions in integrating ethics more within the core courses, in addition to these required courses, which I think will hopefully remain a cornerstone of the education. But I think expanding that to the graduate level education is just as important. So I might be contacting Victoria to follow up.
Okay, thank you. Kyle.
Yeah, so first, thanks for putting this together. I appreciate this. I feel that, right, holistically, people have been talking about the concerns of opening Pandora's box with these sorts of things. The thing that I haven't grasped fully is what is the cost for not opening the box, right? It seems that some of the worldviews associated with the ethical frameworks discussed today fundamentally are at odds with opening the box. But what happens if we don't, right? What are the material realities that we're going to have to deal with if people choose to not work on these things? We don't develop them. This is why I asked Professor Kotichek about what were Russia and China agreements, things like that, right? Because we're not the only people in the world who are capable of developing these things. We're not the only people who are one day going to have them. And so what happens if we don't build them? What happens if we lose the technical advantage that we have, things like that?
Anyone want to chime in? Michael, fantastic.
Sure. Yeah. All right. I mean, I think that's a good question. It's one that motivates a lot of the work that I've done in this arena broadly. And that in that when I think about this and when I think about these topics surrounding autonomous weapon systems or autonomy in military systems more broadly, I tend to think about it in comparison to essentially in a fundamentally relative way, which is relative to two things. One is from an American perspective relative to what others are doing. And we know that China and Russia are investing heavily in these kinds of systems because they view them as ways to potentially disrupt American military power. The second is relative to non-autonomous military systems. In that if one wishes, when we're thinking about what technical benchmarks should be, what reliability benchmarks should be, those kinds of things, to me, it's most useful to have that conversation in the context of, all right, how are they compared to other things, either things that we think are not okay or things that we think are okay, broadly. But I think that it's really important since there are two, in some ways, I think there are two different visions of what the role of autonomy in military systems could be like, which take you down, I think, probably two different sorts of pathways. And I hinted at this in my comments this morning. And the truth is there's uncertainty about this, to be clear. And so the question is then, what do you do under conditions of uncertainty? One is there's a world in which it's difficult to get high levels of reliability with these kinds of systems. And so they really are they're really niche capabilities where it's only in varieties of very specific vision applications or other sorts of things that you could imagine integrating autonomy to the point where a human's even really on the loop, let alone kind of out of the loop. And they're kind of niche capabilities, in which case they're actually probably easier to regulate. And the relative consequences of that regulation might be there's probably some human rights or international law compliance advantages to that regulation that and the costs are relatively lower. The alternative is a world in which embedding autonomy into a variety of military systems is essential for just regular military power kinds of stuff. Like all of the future tanks and planes and ships, et cetera, will have elements of autonomy built into them in ways that might seem uncomfortable today, but maybe don't 30 years from now. And in that case, the counterfactual the cost of regulation of say you comply with something but Russia or China doesn't or something the costs then go up. But the challenge is, again, there's massive uncertainty surrounding, I think, what many of these applications will look like in particular, especially given that most applications of autonomous systems by militaries will not be involving weapons. And so there'll be more in the back office, in logistics, and those kinds of arenas, which I think makes this a genuinely complicated question. I don't know if that's helpful, but I hope it is a little.
Okay, thank you. Ani.
So thanks everyone for a wonderful symposium. It's been a really, really educational day. So I want to sort of call back to some of the ideas that I think Jessa and then Lisa and then Michael followed up on, and sort of this connection between feminism, sort of technology, and sort of, potentially, and the military to some extent. I'm trying to get a take. So if I think about women and underrepresented minorities, right? These are sort of demographics that traditionally and are underrepresented in the technology areas, right? And that sort of percolates throughout in terms of, that's kind of the same thing one can say about the military. And if we think about more broadly policing, sort of firefighting, those kinds of institutions, essentially, right? And so how does this sort of lack of diversity, for the lack of a better word, potentially, how do you guys think this is potentially impacting the way we think about autonomous systems, the way we think about their usage in these military applications, and then how do we, and whether, how, and the fact that the voices, right, sort of the lack of representation to some degree is impacting sort of, our larger take on these issues from a society perspective.
I'm happy to jump in on this, but maybe Jessa, do you want to jump in first?
Well, why don't you go first and then I'll go.
Okay. So thanks, Ani. I think one thing that is really important is, both CJ and Dan mentioned, sort of when we think about the standard roboticist approach, often, it's very formal and use it, and you have your architecture, your task, and your environment was the way that Dan split it up, right? And for me, the way that I would want to think about it, and this relates to what Britt said about integrating these concerns into pedagogy, is when you're a member of an underrepresented group, certain things might be salient to you. So thinking about what is the task, what is the environment? I think the more that roboticists see as part of what they need to do to think about the environment in this larger context, including the social context, to think about the tasks, to include what the socially relevant implications are. I think that's incredibly important. And that's a thing that members of underrepresented groups can bring to the table. So I think W.E.B. Du Bois is credited with saying that people from a more privileged group just walk around with their perspective. But if you're Black or if you're a member of a less privileged group, you need both the privileged perspective and your own for inhabiting the environment. And so I think we miss out a lot with the overrepresentation of men and white people in these fields in terms of thinking about one way of looking at things, one way of thinking about what the variables are as the only way or the objective way of thinking about what the variables are. So I think expanding both the body of people who are working on these issues, but also expanding what we are thinking about when we're thinking about tasks and environments and so on is really crucial.
I would only add to Lisa's remarks that the history of technology is a history of accidents and reworking what was intended. And I think that there's a way where people from underrepresented groups or folks on the margins are better able. So this is like a Donna Haraway perspective, is that like women and other folks who are in some ways on the margins are simply better positioned to be able to reimagine technology simply because their lives, as Lisa was saying, are already so they're already so familiar in a daily and embedded way with having to think along multiple lines. And so that's the basic premise within feminist STS. The thing I would say is the way that often gets taken up within the STEM industry is we just have to get those people in the room, and then we'll be fine. Like if we can just get more women in computer science programs, if we can just get more people of color in engineering, then that'll be fine. And what we know from, you know, from a business perspective and HR perspective, or just simply from a feminist perspective, is that that's really not enough. And in a pedagogical sense, we see that we also need to certainly we need to support students who are there. We need to support junior faculty so that they can have the resources they need to be role models, because once they're in those positions of authority, they often have more work to do and more labor. Within the industry, I would say the frustrations reported by underrepresented groups in the industry is like having responsibility without authority. So they're sort of like in the room and sometimes looked to as like an oracle of like, oh, well, you can fix this, which is unfair. Or other times they're simply like, we're probably familiar with the idea of tokenism, like, oh, look, it's fine. We have Joe here. Joe will fix it. You know, we can point to someone as like being a representation of these ethics that we're trying to live up to. But if the folks who are in the room don't actually have the authority to do, to make those visions, make their perspective felt, then it's kind of pointless and ultimately more of a burden on them. So just to rephrase this a different way, what is key in making ethical decisions is being able to identify the different stakeholders involved in any relationship between humans and technology. And so folks who are on the margins in some way have a relationship to power structure that makes their perspective really useful. But the trick is then to include them, not just like getting them in the door, but also to make sure that their situation, their context, their access to power actually enables them to fulfill even some small part of the vision that we have about what power looks like, or what equity looks like, or what inclusion looks like. So those are some of the logics and the challenges also in this question around diversity and inclusion in STEM.
Great, thank you. I think Fred was next. Frederick?
Can I jump in? Just a comment, I'm sorry, on top of that. So I talked at the end of my talk this morning, I talked about this Minerva Research Initiative project on how you do experiments involving AI-enabled neurotechnology with warfighters, and the response and the role of women, female warfighters who are going to be also using brain technologies. At the first instance in our project on the ethical issues involved in how they respond to the ethical issues involved in being, first users of these technologies, and then down the road, how female warfighters will actually use them once they're deployed. That's going to be, I think, part of our project. So anybody who wants to weigh in on that in the panel or not on the panel, I'd be very interested to hear a response. I don't know, and I'm looking at Mike's little tile on my screen right now. Mike, I don't know if DoD has done gender-based studies along these lines of, have the engineers looked at the way that female warfighters as against male warfighters have dealt with technologies, not just neurotechnologies, and obviously not lethal autonomous technologies. You have an answer? You have an example? I'd love to know that.
I'd say two. Well, first, let me encourage everyone to check out the research of my dissertation student, Shira Pindick, who's going to be on a postdoc next year, whose dissertation's on gender and military innovation, who's exploring exactly these kinds of questions of the role that gender plays in shaping norms of appropriateness about technology adoption, and then the role that technology plays in shaping the roles that are available to women in militaries and how that impacts perceptions of what constitutes a warfighter. I think her work is pretty on point in some ways to some of these questions. I think that, at least from what I've seen, which certainly, if you think about the broad scope of DoD research, is very, is like a tiny bit of it. I think there have been there's certainly military services have done plenty of empirical work in the process of opening up varieties of service roles to women. all of the services have done some empirical work on these kinds of questions. Have they done it exactly the way that all of us from an academic perspective would like think is the best way to do those kinds of studies? I'm not sure. Maybe in some cases yes, in some cases no.
Thank you. That's great. I'm definitely going to follow up with you on that.
I'll drop her name in the chat.
Thank you.
Frederick.
Yes. So I missed, I think, one talk during the workshop, but so this might have been addressed. With respect to test and evaluation and verification and validation, very hard for autonomy systems, hard for automated systems, no standards, to the best of my knowledge at all, for autonomous systems. I feel, and I want to know what everybody on the panel's opinions are of this. I feel that technologies are rushed without testing, without procedures to verify that they're going to behave correctly. I feel like much of the resources, at least from, I'm in the DoD, and at least from the DoD, seems to be going towards pushing things out quickly and demonstrating them versus understanding why they behave a certain way. I'd be curious to get the panel's opinions on this, because this is something that's been upsetting me, at least for the last 5 years. It's the rush to the shiny object and advertise how great this worked on this one thing, but not really understanding it. And that's been very scary for me. So I'd be curious to the panel's reaction to that. Thank you.
CJ.
I mean, it's a wonderful question. I was actually just mindful of an article that I was reading in the New York Times from a day or two ago about the slowdown, if you will, in the rollout of autonomous vehicles. And I feel like really what you're surfacing is more of not understanding the environment. What does a test even mean? Do we understand sort of the complete set of circumstances in which we want this thing to operate? It's one thing if it's going to be inside a building and the temperature is always going to be 70 degrees and it has a a workspace of 6, but things that need to live in the outside world, it's not even clear that we understand what that is. So I think oftentimes there's a lot of good intent, but I don't know that we really understand how to answer the question.
Yeah, and as we move
a
forward,
piece just went up this afternoon. I'm really annoyed that it didn't go up yesterday. I would have incorporated my talk exactly on this point on the Times site in terms of self-driving vehicles and the fact that the goalposts keep getting pushed back, and it's the same problem I think you're referring to about dynamic environments. Not even nowhere close to what the promises were a few years ago.
Lisa.
Yeah, thanks, Fred. I mean, I think this is exactly what I was trying to get at when I was trying to reframe some of the issues about meaningful human control in terms of permissible uncertainty, right? So with these kinds of systems in these complex environments, there's no way to reduce all the uncertainty. We have to figure out which is the uncertainty that we need to reduce in order to fulfill our ethical obligations. And I think that if I were to articulate what I thought was the most important thing for roboticists to come together and try to work out is how we should think about posing these questions about uncertainty that then we can go and answer them in a rigorous way to the best of our abilities.
This is really great. So I love that question, and I love that Lisa jumped in. Going to Dan's kind of mission statement for this group and for our moving forward, I think this is one of the points that we should definitely hit in all the future workshops. It's a really great point. Jesse.
Hi, thank you. So building off Kyle's question, is there a sense that we may have some sort of moral obligation to warfighters and civilians on the battlefield to develop these systems? And I understand why there's this aversion to machines assisting, soldiers in combat or taking kinetic actions against the enemy. But the alternative is that humans are going to be the ones making this decision, and not just any humans, but particularly young and vulnerable humans that may not make the best decisions just in general. And speaking as someone who's been in combat and been in firefights, there are so many different challenges that these young warfighters face. There's epistemic challenges, not having complete information. There's state of mind challenges. Decisions are driven by fear or perhaps anger, and all of these are going to cloud judgment and result in potentially poor decision making to begin with. So the bar is pretty low. And just to take a firefight, for example, it's incredibly chaotic. Mistakes are going to happen with humans. And not only do you not want to be the person pulling the trigger by mistake, but you don't want to be at the other end of that mistake. So I guess, is there some sort of obligation to stakeholders on the battlefield to develop these technologies?
This is a great question. Actually, Michael and I were talking briefly a little bit about something kind of related, which is, people have the warfighters, typically they talk about rules of engagement. There are certain conditions under which you can use force, and essentially it's like an algorithm. And so you can start comparing, if it's an algorithm, what if a robot does it instead of a person? And you bring up a really good, interesting thing, is the impact that I don't think ever came up, is the impact on the person pulling the trigger. People don't usually think about that, but that is also really interesting. But perhaps, Michael, I don't know if you want to answer this.
Sure. I mean, I think my instinct here is to break this down into different kinds of autonomous weapon systems in a way, and to, distinguish between the different, in that, I think one of the last places will ever see these kinds of technologies used is directly on the battlefield in an individual way. And this in some ways reflects my perspective on the first thing that I said like a half hour ago or so. Just in that, I think that the concern about getting the rules of engagement right and how we think about accountability in those situations will tend toward use of autonomy more against material, against tanks and planes and ships, rather than against individuals. If you have vision algorithms that can distinguish between a human and a rake, that doesn't necessarily, that doesn't mean they can figure out what a lawful combatant is. But I think though that the cycle, given what let me say one more thing about that. I would say, given what we know about the PTSD rates in drone pilots and how they look very similar to PTSD rates of pilots that are, out on the battlefield or above the battlefield, I guess in that case, it makes perfect sense. I mean, we should absolutely need to be thinking about this in some ways, the very human consequences for the war fighters who will be engaged. And that's an area where I've actually seen very little work done up to this point. Most of the work tends to be about the sort of accountability questions involving the targets, if you will. So I think it's actually a really good question where I actually haven't seen a ton on this. Kind of curious if Claire actually has a perspective on this, given her legal background.
Yeah, I was going to say, I mean, from the evidence that I have seen, the levels of PTSD among drone operators are actually higher than levels of PTSD from those on the actual battlefield, and that is a fascinating fact about human nature. I think it's something that we really need the help of psychologists and cognitive scientists to try to understand. Now, on the ethical implications of that, I mean, I absolutely think that we have ignored the psychological impact on our own troops as we think about various deployments and various interfaces with technology. But one of the things that it suggests is that we need to start thinking about those consequences as, almost like collateral damage, which is odd because you don't think about the impact on your own troops as a form of collateral damage. But psychological, we don't have a very good way of tying psychological effects and accounting for psychological damage as part of the direct effects of decisions that we make in warfighting. I have a question, but it's on a slightly different topic. So maybe
well, I just want to jump on this for a moment to Jesse. There are a few philosophers who are interested in the problem of the moral burden on warfighters. One of them is maybe you know a guy named Mike Robillard, who was an Army Ranger. He's now on some kind of a postdoc or something at Notre Dame. But there are a few people who are thinking about this, not necessarily in the realm that we're talking about today, but in general. And it is I think it's something that people are concerned about, but not a lot.
Well, we do have a volume on this topic, and Jesse has been involved in helping get that volume out in my series, in the Oxford series in Ethics, National Security, and the Rule of Law. And it's directly on this topic. So
I should have known that. So
would you put that out on the chat kindly? The site.
Sure. Yeah. Though it's still a little bit far away. Jesse, maybe you have the details on it, and you can put it in.
I'll throw the details in the chat.
Thank you.
There, you have another question?
Yeah, the question that I really wanted to hear from the GRASP Lab folks on is, we've spent a fair bit of time today. Some of the talks talked about legal and ethical constraints on the development of technology, but one of the things that I really hope we can have an ongoing conversation about is modeling ethical reasoning. Because, as I said in my talk, I think it's inevitable that there's going to be a lot of pressure on the place where we have currently drawn the line. And, the idea that there has to be a human in the loop and what meaningful human control means and all of that, the way these things tend to happen, of course, in law and with general ethical norms is we start redefining what counts as meaningful human control. And we start peeling back the onion on that concept. And we start saying, well, it doesn't have to, they don't have to be involved at this point. They don't have to be involved at that point if there's certain design constraints and so on. And one of the things that I think those of us who do ethics and the law of armed conflict really need help with is your thoughts about what it means potentially for an autonomous system to think ethically. And has there been any attempt really? I know there's been a fair bit of effort to try to capture ethical reasoning in the medical ethics field, and maybe Jonathan has some thoughts about that. And my understanding is that those programs are somewhat hit or miss. Though I gather the diagnostic programs have improved a lot in accuracy, but ethical reasoning is different than accuracy in diagnostic reasoning. And it's one of the most interesting things that I think has come out of some of this interdisciplinary work between, engineering, cognitive scientists, philosophers, ethicists, and so on, and lawyers, is that it's forced us to think more about the human mind and to think more about what it means for human beings to reason ethically, what constitutes ethical reasoning on the part of human beings, because until we figure out that, we don't know what we're modeling. So I'm very curious to hear any thoughts from engineers or.
Could I jump in quickly and then get out, because it's beyond my pay grade in some sense. I think you'll be disappointed by the quality of the formal reasoning. We certainly have that kind of stuff. We call it game theory, right? Or differential game theory. And it's not like we don't have formal ways of thinking about this, but I believe you'll be disappointed in the ethical competence along the lines that Lisa was in some sense chiding me for always wanting to take a formal point of view. Of course, that's what we would like to do, but I think to date, you'll be disappointed in the outcomes of the extent to which we've tried to do that. But it seems to me a really, really important intellectually exciting, but morally important undertaking to try to engage with you and people like you, and seeing what the limitations, seeing how to fix those limitations, perhaps using underrepresented voices to help, blah, blah, blah. I'm going to stop right there.
CJ.
Well, I guess there's sort of two responses that sort of sprang to mind in your question. One is, as a computer scientist, we tend to think of our machines as completely plastic, as Mark was saying. If you give us a set of rules of engagement, we can code them in. That'll be an afternoon's work, which is a very flip answer, of course. The thing that tends to, of course, trouble me more is this question of uncertainty, and sort of this. In some sense, we can imagine sort of coding a utilitarian perspective into our robots, but conveying kind of what we think our algorithms are telling us and what they are, and the error bars around these is part of, I think, what gives me great pause, is that, you know, does a robot really know that that's a person, or do they think that they're a rake? It's a very real thing.
You know, we're back to Ron Arkin's work 15 years ago. So I'll just say that. Secondly, just the thing on, since, you know, Claire asked about bioethics, there's all this talk about robotic surgery. And every week there's there's a new article about breakthroughs in robotic surgery. Having done some work on innovation in surgery, empirical work, a problem for so-called robotic surgery is that you have to be creative sometimes. And the algorithms just don't always tell you how to cut and where and what to sew together. You talk to surgeons, there's a surprising amount of innovation that they do on the spot that is never written up in a journal article. So I'll just say that if you're working, again, in a dynamic environment, whatever you're talking about, whatever the context, it's the same problem keeps coming up.
I will tell you just briefly that we did also, in the same series that I mentioned, we did just publish a volume edited by Jai Galliot. I don't know if folks know his work, and a few other people, which is an edited collection on lethal autonomous weapon systems. And I will put that link in the chat. And we may have an event in the upcoming year to talk about that volume. So I certainly welcome the participation of anyone who'd be interested to be involved in that.
Just, thanks, Mark. I mean, just to jump in on this is something, Claire, that I think it's super important, and it's something that I spend a lot of time working on, how to think about our human mental capacities for reasoning and how that relates to artificial and robotic systems, and what we can infer from the interplay between AI and cognitive science and philosophy. And just to put out a concern, I think that there's a lot of echo chamber back and forth that's happening. So you have people in cognitive science who try to develop these simplistic computational theories, then people, because they think they'll be implementable either by biological or artificial systems. And then you have the AI people who pick up exactly that stuff because they say, oh, I know how to build a robot that does that. And then the cognitive scientists go back and they say, well, the AI people are doing that, so that must be a good way of thinking about reasoning. And so you have this artificial bootstrapping of certain ways of thinking about reasoning. And so
I think you're absolutely right about that, Lisa, yeah. By the way. I have noticed that as well.
Yeah. So I'm happy. I would love to talk with you more about it sometime.
Let's have lunch.
That would be great.
Kyle.
So I think there's been interesting interplay between discussions of ethics, but then also of efficacy, right? I think ethics is a matter of like, should we do this versus can we do this? And like, how do we do this effectively? One of the things that it seems that some of the other speakers asked about, at least in passing, and I haven't really gotten a clear answer on, is how do you do robust evaluation compared to, say, the human baseline, right? So Jesse talked about in combat, the humans tend to have problems with like knowing where to aim, right? Dealing with fog of war, things like that. I mean, this is the same problem with humans driving cars, right? The self-driving car industry, people imagine this ideal human that's really good in all situations. But I mean, honestly, people drive down the highway texting. It's like, how do you actually evaluate against these sort of like real baselines? And how do you do the trade-offs where you say, okay, I have an artificial agent. It's worse than humans in some capacity, but better than others. How do you decide the places where it's better outweighs the costs where it's not? and that we should still put this in the field? And how do you avoid hand wringing where you spend too much time evaluating it and ultimately never deploy it, and in the interceding time, right, you're paying a cost for not deploying it, right? How do you do this? And this, I think, is a policy question, right? How do you set up policy in order to avoid too much hand wringing, too much delay, while still doing sufficient vetting to ensure that you are above the prior approaches to doing these things?
That's like the $1 million question to some extent. If we could answer all those, I think that's part of what we're aiming for. But does someone, like, maybe, I don't know, Michael, do you have something that you can say towards this if it's a policy thing?
Yeah, I mean, I think that I think some of these things are easier to do than others. I mean, you can pull together data, like say you're interested in like accident rates for different kinds of systems. Like that's a technical question in some ways. And now you can measure out in the field, or if you wanted to look at how a system performs compared to humans, you could probably use like you can probably use some of the like training grounds out in California to derive a human baseline, from which then you would test. To Fred's point, I think the challenge becomes, how do you, in some ways, like, how do you know that even if in like a controlled environment, when I say like an algorithm empowered system or something, performs like a certain way, a certain percentage of the time, how confident are you that it will actually work that way? Would it, in some ways, like when it encounters the fog of war in a situation where maybe the training data doesn't completely, doesn't like perfectly capture what the reality of the world is, but like that, I think, is like the T&E and V&V challenge, or like the big challenge from of like a validation and testing and evaluation kind of perspective. I think you could, I mean, if some of these systems get far enough that you're talking about incorporating them as programs of record and integrating them into how services operate, like at the pointy end of the sphere, then presumably you would want baseline. You would have to have baselines in some ways for how they compare to other systems. Otherwise, like, how would you be able to make policy choices? Since, I mean, and I did this to Mark over in the other book, and he and I were chatting before, but like, to me, like, one of the big questions is, if one thinks an autonomous system might be philosophically okay in a given area, should the performance that we require from it be the same as a human, or should the performance we require from it be better than a human? And I can imagine reasonable people disagreeing about that, depending on what you think about uncertainty in this context, or what you think about, or if you're trying to focus on buying down like public or expert fear, or I don't know, like different people might have different answers to that.
Can I just say briefly in response to that, just to follow up on what you said, Mike, because I think you put your finger on such an important question. And I have another paper in which I discuss this, where I ask the question, if human beings are fundamentally ethically flawed in the way that they reason, are we trying to capture those ethical flaws when we model human reasoning with autonomous systems, non-human autonomous systems? Or do we think that we can construct some kind of, ethical algorithm that would be an improvement on human ethical reasoning, right? Because human beings are notoriously ethically flawed. So I think here is a critical normative question. The idea of deliberately building in ethical flaws to a system that we're trying to create that has control over life and death is appalling, but yet we're not so appalled when the autonomous creatures that we are the ones making those flawed decisions.
Claire's talking here about the question of representation and what we're representing in these robotics, and that's an important question, but it makes me think about the example of using algorithms in sentencing guidelines for parole, and using algorithms in sentencing guidelines for judges. And that raises the issue of when we're talking about the ethics of as distributed between humans and technology, there's this deep desire for accountability, and it seems fundamentally unsatisfying, at least in the case of algorithmic sentencing guidelines, that there's simply no accountability, no meaningful accountability when you look. There's a transparency issue, like can we understand what exactly goes into the algorithms? But the larger issue from a social justice perspective is usually framed in terms of accountability, where it's actually more desirable to be able to look at a judge and say, that's the person who has done something, that's the person who has made this decision. And so I just wanted to, that's been on my mind as we've been having these conversations about not just the ethics of like, do we have the technology to do it, or how are we going to code our own guidelines into it, but where accountability lies. The other thought I had just now was like, there was a great article, if I can find it, I'll put it in the chat, about technologies that we have asked to lie to us. So technologies that we have asked to deceive us. And my favorite example is a bus stop outside an assisted living facility for the elderly. And if you've had a loved one in your life who has, just had memory issues or Alzheimer's or dementia, they'll often go to a bus stop to try and leave. And so they have a bus stop, no bus ever comes there. It's just they built the bus stop as a way to sort of gather the residents who are always trying to leave. And so it is a technological arrangement that we have asked to lie to people because we understand that is better, or that it plays a useful role in terms of like caring for people. So there certainly are times where we look at human frailty, we look at human flaws, and we say, well, we're going to build something that responds to that. So in that sense, that's always been a useful example to me in thinking about the ethics of our relationships to technology.
That's wonderful. Oh, yeah, CJ.
Oh yeah, I just wanted to respond to this question. I think it's a fascinating one. In some sense, to me, it sort of resonates of how do we know what we know. And I guess there are wonderful cases where we actually are able to build, precise mathematical models that we think capture the relevant aspects of what's going on. So let's say terrestrial mechanics, or when you want to shoot rockets, and then we can have mathematical proofs, and that gives us a reasonable context in which we can claim to know what we know. The systems that we're building now, of course, if we're arguing into our engineering colleagues, really are based on data sets. And this is, of course, problematic in that sense. The data sets can be subject to bias in various ways. But honestly, the way that you get a paper published is there is a standard benchmark. Their method does X, my method does X plus 1. And when that data set gets exhausted, we put another data set and another data set out. If I'm being frank, honestly, when we're talking about just deploying the kinds of technologies, self-driving or the like, that is the proof that we have to offer at this stage. I haven't seen sort of another competing method that purports to speak to this issue of efficacy or to getting papers published from a more narrow perspective.
Thanks for that.
I'll just jump in on the
please.
I have a friend who teaches in business schools and also advises companies on who are developing companies that are developing self-driving vehicle systems. And he has a very subversive response to the trolley problem, which is, it's an insurance question. Whether you put that trolley down one track or another, hitting the obese person or the 3 children who have no dependents, it's going to be solved by the liability system, which is a shocking but kind of interesting angle on this. Now, that might work ultimately, for self-driving vehicles, but autonomous weapon systems, maybe not so much, unless you require, as I don't believe we currently do, and I'm looking to the law professors here, the weapons of war manufacturers to actually be liable for their systems at law. Claire, I know you're shaking your head.
No, we don't do that.
Right.
And there wasn't even much headway. I think there was maybe one decision holding manufacturers of Zyklon B responsible for some of the deaths. in the Holocaust. But no, we don't do that, and it would be you know, a machine that's designed to kill versus a machine that's designed to get people safely from one location to another. You know, very different matter, but the ethical responsibilities of the defense industry, you know, needless to say, there's much work to be done there.
So thanks for this. We are running a little short on time. I threw myself a raised hand because I wanted to ask a question, actually, just real quick, that I think is a little bit more focused towards what I think might be the solutions towards what we are looking for from a robotics point of view as we think about autonomous systems. And that is like clearly one of the things we have to do is figure out what does it mean to be autonomous. And I want to actually pose this in terms of a question. And mostly it's towards towards Lisa and the 5 levels of autonomy. And so if we have a perfect system, like where the doubt is gone, the uncertainty is gone, and you program a robot to whatever, kill someone, you have specified some kind of parameters for people or person that you want the robot to kill. It goes out, you know, maybe it's the whatever Latin thing for describing the type of person to kill. I propose that if we could say that a bow and arrow is L5, it's the same thing. A bow and arrow is autonomous. You fire an arrow, the characterization description of anyone who happens to be in line of the arrow is the one that you hit, and it's the target. Then as soon as you let go, it's autonomous. It's flying there. And from the uncertainty point of view, it's your understanding of how it works. From a robotics point of view, your understanding of how well the robot works. It's essentially the same thing, and it's ultimately the person's responsibility of when you shoot. If you're pulling a trigger, when do you pull the trigger of the gun? With a robot, when do you set the robot out to go? And ultimately, it's the same thing. So autonomous system is maybe autonomous is not really that scary. Is it essentially the same thing?
Thanks, Mark. I basically, yes, is what I would want to say. So I think the term like autonomy is one that is like these other terms like decision-making or reasoning, where when we think about autonomy in individuals, where that's connected with agency and responsibility and so on, it's this very loaded thing. Autonomy in weapons means something very different. And the particular notion of autonomy that is in the definition of autonomous weapon systems, where it's something that can select and engage and deploy a weapon aimed at a target on its own, that's very different from the notion of autonomy that's related to human decision making. And so what I would want to suggest is that if we could reduce all of the uncertainty, so in the bow and arrow case, right, part of being a skillful archer doesn't just involve knowing how to shoot and how to hit your target. You have to be in the kind of environment where the uncertainty about certain things running in that you really can't shoot aren't gonna be there, right? So if you think about hunters who deer hunt, and with bows and arrows, some people still do this, right? Part of the ethical obligations for those hunters involves knowing that you're in the conditions where you're not going to hit something you don't intend to hit, right? And so that's how I would think about autonomous weapon systems. The issues there are, of course, much more ethically complex, but I think they're essentially of the same nature, where what you're asking is, what kind of assurances do you need in order for the human who is saying, yes, use this autonomous weapon system? What kind of assurances do you need such that that person can ethically make that decision? And so this goes back to Jess's point about accountability, right? Which I think is raised in other non-military systems too. The accountability question should not, is there shared accountability between machine and human? But how do you reduce the uncertainty so that you can ask proper questions about accountability for the people who decide to use these systems?
Right, fantastic. Drew, last question.
So this builds right off of what we're talking about here. We've thrown around the word uncertainty a lot today, but in the world of robotics, uncertainty can come in many different forms. We have things like sensor noise, drift in our sensors. We have uncertainty about our models that represent the physics of our system. We have uncertainty about the environment. What do we mean in an effort to try to facilitate a deeper level of discussion? What do we mean here when we're talking about uncertainty? Because some of these things we can solve directly through engineering practice, and other things are much more abstract. And as a roboticist, I need help understanding what we are actually talking about when we're referring to uncertainty.
Can I quickly jump in on this, and then I would love to hear what other people think. So I think that taking a contextualized approach is imperative here, and it returns back to some of the issues about representation and inclusion that people were talking about. So if you think about reducing uncertainty for face recognition software, right? It's crucially important that the data sets people use tend to be white faces, and the contexts in which they're used in the criminal justice system tend to be primarily people of color. And so it's a crucially important, issues about race are crucially important in issues related to uncertainty and what data sets are appropriate or inappropriate and so on. And so to go back to something that CJ was saying, I would suggest expanding the roboticists and AI theorists' view of what we should be doing in terms of justifying the data sets and the benchmarks in a much more socially relevant, contextualized way.
Other thoughts on uncertainty?
Yeah, just to very quickly, so I know we're almost out of time. I mean, I would think about it when I would say from a policy perspective, not an engineering perspective. Uncertainty about performance is about, probability that a, system performs as it performs as intended. As intended meaning sort of, like in the, in the lab, like if you fire like think about this, like we were talking about like a Tomahawk missile that should have like a circular error probable of like 3 feet or something, what percentage of the time does that missile actually hit within 3 feet of that which you aimed it? And so uncertainty being in this case being if we lack, I mean, in some ways this is actually whatever, this is kind of a repeat of what Lisa said in a different context, so I'm going to shut up in a second, but just if we're actually not sure how often we can get within 3 feet because the algorithm like isn't very good for a variety of reasons, then the question becomes, how do we improve the technical question is how do we improve the algorithm? The policy question is how good do we want the algorithm to be before it's okay to use?
I'd like to just jump in to merge the Lisa and CJ point, which is, we have as practitioners, we have the obligation to have the Claires and the Lisas and the Jessas help us figure out how to model some of these sorts of uncertainties that we have and scopes that we haven't been able to on the one hand. On the other hand, we need to do, since science is a social construction, we need to do work in our own disciplines to make sure that actually you can publish papers that have formal or as formal as possible, or at least as methodical or methodologically sound as possible, rather than just publishing to the shiny object, as CJ eloquently points out, is now the prevailing practice. So I think there's a lot of work to be done, and it's extremely encouraging to me to listen to the kind of exchange that we had today. I really think that it may be possible to do this, and we know that we need help. And I think what I'm hearing is that there are lots of people here who are willing to help.
Can I jump in very briefly on the uncertainty point? Just to remind us, of course, that we need to distinguish between processes that are certain, where we don't have enough information, and processes that are actually uncertain, and then even further processes that are indeterminate, and that these are actually 3 different concepts. And so one of the profound questions I have about autonomous systems is in what sense their actions are uncertain. Are they actually sort of indeterminate? I mean, that obviously gets into questions about free will and responsibility with regard to humans that are, now at 5 o'clock we're not going to get into, but these are profound questions that I think also belong at the intersection of the sort of work that philosophers and lawyers do and the sort of things that you're doing at the GRASP Lab.
Thank you, Claire. It is 5 o'clock, and I want to give Dan the chance to close us out. But before we do that, I'm super impressed by the level of talk that we had today and all of the participants. And it's kind of interesting to see that usually what you see is when you have something like this, there's a bunch of people and then they start disappearing in the panel session. They get smaller and smaller. And it seems like everyone is still here, which is just amazing. So an important thing is also we've got this survey that's come out that Dan will talk about. But so Dan, if you want to, or Michael, if you want to close us out.
I can just mention that the survey, I think you're going to get the information about the survey in an email very soon. And we beg you to try to fill at least as much of it out as you have time to do. And if you are as motivated in the future as you seem to have been today, for which we are enormously grateful, we'll be even more enormously grateful if you sign up to join us in some fashion. You know, we'll be sparing in our asks of you. But we need you. We need this diversity of thinking to move ahead. So, Mike, I think you're the world's expert in these domains. I think I'm going to let you close us out.
I don't know if I'm really an expert in anything, and in some ways today's reinforced a lot of the things I don't know. But I'm really grateful that both for our other panelists and for Mark and Dan in putting this together, and to the GRASP Lab, and to everyone that's joined the conversation all day. I mean, I think that this is a tremendously important topic and a clearly interdisciplinary one that has normative aspects, has their social science aspects here, their engineering aspects. I mean, this is to me is a topic where the knowledge of the university, you know, thought about broadly, actually has a lot to say. And so I'm glad that we could put together this, you know, very distinguished group of people who have so many different perspectives on these topics. And I hope that this is only the beginning of the conversation. And I know that Dan has lots of plans for that. So thanks, everybody.
Thanks. Let's get everyone a hand, all the panelists, all the participants. Wonderful. Fantastic. Thank you. Thank you.
To be continued.
Thanks so much, Dan, Mike, everybody. Thank you.
Fantastic job.